Section E, 31st, first part. Draw ray diagram for the formation of image of a point object by a thin double convex lens having radii of curvature R1 and R2. Hence, derive lens maker's formula. Second, a converging lens has a focal length of 10 cm in air. It is made of a material of refractive index 1.6. If it is immersed in a liquid of refractive index 1.3, find its new focal length. 31st first. This is a convex lens having radius of this surface P1 will be, the center will be C1 and radius will be R1. This surface P2 having centers here C2 and the radius R2. A ray is incident on the surface. Since this will be the normal, so this ray will, because it is the denser medium, this is the rarer medium, mu1. So this is air, this is glass and this is air. So this is denser. So it will bend towards the normal. So towards the normal means this side. So it will just meet at this point if this surface is not there. But since this is the surface here and this will be the normal, so it is moving from denser to rare, so it will move away from the normal. So this will reach somewhere here, this I. So the ray goes from here, it is rare to denser, so it will bend towards the normal. Then for this surface, this is denser medium, this is rarer medium, so it will bend away from the normal. So instead of going this way, it will bend further and will reach at I. So if we take this ray directly, so it will pass throughout as it is without any deviation, because it will be at 0 degree angle of incidence. So for surface P1, mu2 upon this distance will be, suppose V1, this distance is suppose V and this is U. So for first surface, mu2 upon V1 minus mu1 upon U equals to mu2 minus mu1 upon R1. This will be equation number 1. Then for surface P2, means second surface, for this surface, the second medium is mu1. So mu1 upon image V minus first medium mu2 upon the object. For this surface, this is the object. So it will be V1 equals to mu1 minus mu2 upon R2, which can be written as minus mu2 minus mu1 upon R2. So just adding equation 1 and 2. Adding equation 1 and 2, we get mu2 by V1 cancel out, and simply we get mu1 upon V minus mu1 upon U equals to mu2 minus mu1 into 1 by R1 minus 1 by R2. So if we just take common mu1, I'll just rub it, or we can have it. So 1 upon V minus 1 upon U equals to, this mu1 goes this side, so it will be mu2 by mu1 minus 1 into 1 upon R1 minus 1 upon R2. So we know this 1 by V minus 1 by U is 1 by F as per Lenz's formula. So it will be mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2, or we can simply say this 1 by F equals to mu minus 1. This mu2 divided by mu1 is always mu. Refractive of the second medium is the first medium, and this will be 1 by R1 minus 1 by R2. So this will be the lens maker's formula. So for 31st part, please refer YouTube link of Jeevan Safalta Sutras. The link is provided as under. Now 31st second part, a converging lens of focal length f1 is given you 10 centimeter in air, that is Fa in air, is made of the material of the refractive index mu g is equals to 1.6, and now it is immersed in a liquid. Mu L equals to 1.3. Mu L is equal to 1.3. So we have to find F liquid. That is the question. So according to lens maker's formula, 1 by F air is equals to mu G upon mu air minus 1 into 1 by R1 minus 1 by R2. Similarly, 1 by F liquid will be equals to mu G upon mu liquid minus 1 into 1 by R1 minus 1 by R2. This is equation number 1, this is equation number 2. Equation 1 divided by equation 2, we get FL upon FA equals to mu G by mu A minus 1 upon mu G upon mu liquid minus 1, and these two will get cancelled out. So which you can say mu G is 1.6 upon air is 1 upon mu G is 1.6 upon 1.3 minus 1. So that is equals to 0.6 upon 0.3 upon 1.3. So here F liquid is equals to 0.6 into 1.3 divided by 0.3 into F air. So that is equal to 6. This is 2.6 into F air is 10. So it will be 26 centimeter. So the focal length in liquid will be 26 centimeter. 30th hour part 1. Define a wavefront. How is it different from a ray? Second part. Using Huygens construction of secondary wavelets, draw a diagram showing the passage of a plane wavefront from a denser to rarer medium. Using it, verify Snell's law. Third, in a double slit experiment using light of a wavelength 600 nanometer and the angular width of the fringe formed on a distant screen is 0.1 degree, find the spacing between the two slits. Fourth, write two differences between interference pattern and diffraction pattern. Wavefront is the locus of all the vibrating particles which are in the same phase. Let us say like this. So if we trace these, so this is the wavefront, it's the locus of, or we can say it is the surface where all the vibrating particles are in unison. That means they have the constant phase difference. What is the difference between the ray and the wavefront? Ray is always perpendicular to the wavefront at all the corresponding points. Whereas this wavefront tells us that the points or the vibrating particles or at these points will be always in unison or with a constant phase difference. Ray of light gives the direction of propagation of the wave, whereas wavefront tells us which particles are in unison or in constant phase difference. This is the OR part, 31st OR part, second, using Huygens construction of secondary wavelets, we have to derive Snell's law. So, this is the wavefront. So it is denser medium and this is the rarer medium. So this ray, this is the angle of incidence. The angle between the wavefront and the surface plane is always angle of incidence. So since this is the rarer medium, so it will go away. So it will move like this, and similarly this will move like this parallel to this. So this is the wavefront and this will be the angle of refraction. Since this is a denser medium, so it will travel a less distance in the same time as in the rarer medium. So the distance traveled in the same time in rarer medium will be large. So if it is A, wavefront A dash, and this is B dash, then A dash B will be always less than AB dash, because AB dash will be greater, because here the speed will be high, here the speed will be low, but the time taken will be same from reaching A dash to B, will be same from reaching A to B dash in the rarer medium. So if we consider a ray from K, L, and then it will move parallel to these to M. So time taken to reach the wavefront from K to M via L will be equals to KL upon the velocity in the first medium plus Lm upon the velocity in the second medium. So KL will be equal to, this is 90 degree, so this is I, so KL will be AL sin I upon V1. So again this is 90 degree, this is R, so this LB will be, LM will be LB sin R upon the velocity V2. So here this is AL sin I upon the V1 plus LB can be written as AB minus AL. So it is AB minus AL into sin R upon velocity V2. So AB sin R upon velocity V2 plus AL common, sin I upon V1 minus sin R upon V2. The time A dash takes to reach B is same as A reach to B dash, so will be the K to M. That means if I consider this from here to this way, again there is no difference in time period. That means this t is independent of AL. If AL is small or large or this, it is not going to make any difference. But mathematically, this t is depending on this. So it will be only possible when this whole factor becomes 0 always. That means sin I upon V1 minus sin R upon V2 has to be 0. Which means sin I upon V1 equals to sin R upon V2 means sin I upon sin R equals to V1 upon V2, which is nothing but refractive index of the second medium is equal to first medium. So sin I upon sin R equals to mu, which is Snell's law. Third part और का, here the lambda is given 600 nanometer in a double slit experiment, and the angular spread was found 0.1 degree. So we have to find the slit separation between the two slits. Slit के बीच का डिस्टेंस निकालना है. लैम्डा ये दिया हुआ है, थीटा जो एंगुलर स्प्रेड ये है. We know that theta equals to lambda by d. So d will be equals to lambda by theta. Theta is equal to lambda by d, d is equal to lambda by theta. So this d will be equal to lambda is 600 into 10 to the power minus 9 divided by 0.1 into, that is to be converted into radian, that is pi by 180. So this will be equal to 600 into 180 upon 0.1 into pi into 10 to the power minus 9. So that will come to be 1 0 here, so 3 and 1 4. So it will be 6 into 18 divided 22 by 7 into 10 to the power minus 1, 2, 3 and 4. So it will be 5. So here you can have 6108 into 7 divided by 22 into 10 to the power minus 5. So this 22 is 11 and this is 54. 54 into 7 is 7 4s of 28, 7 5s are 35 and 37 divided by 11 into 10 to the power minus 5. So here it comes 11 3s are 33, then 4, 11 4s are 44, then 4, 11 3s are 33 and 11 6 are this into 10 to the power minus 5. So that you can write 3.44 into 10 to the power minus 4 meter. That will be the answer. Now fourth part, difference between interference pattern and diffraction pattern. First difference, the interference pattern is produced by interference of or superposition of the two waves coming from two different sources, whereas in diffraction there is only one source and the waves are superimposing at a point from the upper half and the lower half, means corresponding waves from the upper half and the lower half, they are superimposing and the pattern is produced. The second difference is the intensity of the interference pattern, the fringes or pattern of the maxima is same, but in case of diffraction pattern, the intensity of the maximas is not same. Third, you can say, in case of interference pattern, the bands or the fringes are of large number, whereas in case of diffraction, the bands or the fringes are of small number. A few bands are there. Ultimately, they just vanish because the intensity falls very rapidly. Next difference, you can say, here the band width or the width of the bands maxima or minima, they are all equal, whereas in case of diffraction pattern, they are not equal. You just see the interference, the central maxima is twice of the width of the other maxima. One more difference you can say, that here the dark fringes are completely dark, the minimas are black or dark, but in case of the diffraction pattern, the minimas are not perfectly black,